All right, we're getting close to the end now. For this extend your learning question, um, you have a complex shape that you're going to decompose into simpler shapes and then find the area of the entirety of this arrow sign. So it says the sketch shown below is for a commercial sign. It was drawn to 1/10 of its true size. So that's going to be important information right there. What is the area of the actual sign? Prove your answer by showing all calculations. Note each grid unit is equal to 1 inch. All right, now I'm not going to work this entire problem. Instead, I'm going to help get you started because at this point, you should be starting to get a little bit more confident in finding the area of rectangles, finding the area of circles, and finding the area of triangles, which is what this shape is made up of after you get done deconstructing the shape. All right, so I have a really poor sketch of that shape, and I just wanted to show you kind of how I broke this up. There are many different ways that you can break up your sketch of this sign, and so what I did is I turned this first one into a rectangle. So I found the area of this rectangle, which I feel like you all would be successful at doing. And then I had my triangles, so 3 different triangles. So I found the area of triangle number 1, found the area of triangle number 2, and then found the area of triangle number 3. Okay. Then finally, you have a circle. So this is half a circle though. So you'll solve for the area of a circle, and then after you find the area of the circle, cut it in half because it's only half of the circle. Okay, so you will need 3 different formulas. So area is equal to base times height for the rectangle. So base times height for the rectangle. All right. And then for the triangle, you'll have area is equal to base times height divided by 2 is the triangle. Okay, and then the circle, area is equal to pi times radius squared, but you will need to divide it in half to get half the circle. Okay, so make sure you remember that. So you'll end up with 1 triangle, 2, 3 triangles, 1 rectangle, and half a circle. Okay. Then you will add up the area for each one of these. So you'll find the area for each one, add them up. So you'll get the area for this, the area for this, get the area for all this, and you'll add that up to get your final area. But wait, important step. It's 1/10 of its true size. So each grid unit is equal to 1 inch. But whenever you get your final area, you'll then need to multiply the final answer by 10 to scale it up to represent the true size of the sign, because otherwise it's going to be too small. So you'll need to scale this up to represent the true size of this sign. Okay. And then we have a few conclusion questions. These conclusion questions, for the most part, can be found in the presentation. So what is the difference between a circle and an ellipse? So you can come back up here, take a look at a circle. Okay, circle is the simplest and strongest of all shapes. Let's see here. This is how to solve for it. Oh, here we go. This is what I want. A circle is a round plane figure whose boundary consists of points of equal distance from the center. So from the center, equal distance all the way around, whereas with an ellipse is generated by a point moving in a plane so that the sum of the distances from the 2 other points is constant and equal to the major axis. Okay, so that's where you're getting into the differences between the minor and the major axis. What is the difference between an inscribed and a circumscribed shape? So here we go. We had looking at our polygons, where we had an inscribed polygon is the polygon placed inside a circle, whereas a circumscribed polygon is a polygon placed on the outside of a circle. Okay. Why is it impossible for a triangle to contain a 100-degree angle? It would be impossible for a triangle to contain a 180-degree angle because a triangle, by definition, all the interior angles add up to be 180 degrees. So therefore, it would not be possible for that to happen because they all have to equal 180 degrees with the three different sides. So let's see here. If it says straight up. And here's another example of circumscribed and inscribed. But that is the answer, is all the interior angles add up to be 180 degrees. And if you were to have a triangle that was greater than 180 degrees, you're not probably working with a triangle. How is a rhombus similar to a square? Well, a rhombus and a square are similar in that their sides are all parallel to one another, whereas a square, all sides are parallel and equal. That is not the case with a rhombus. The rhombus, the sides are still going to be parallel, but they might not be equal length to each other. And then what is the difference between a right angle, acute, and obtuse triangle? And so that's right here. So acute is less than 90 degrees. A right angle is exactly 90 degrees. And then obtuse is between 90 and 180 degrees. Okay. And that should finish up the assignment. Make sure that you include, you don't have to write the question because obviously the question's there already. In the past, when I had kids do this in the notebook, they needed to include their question, but you do need to write a full and complete sentence for each of these conclusion questions. Once you're done, make sure you put your name on it and turn it in.